Okay, so we will be starting with the session now. Hello, everyone. Dear authors and invited guests, welcome to Technical Session 11A. My name is Dhimahi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held through Zoom from 9 to 11th April 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, before we start with the session, I would like to introduce you all to the chair of the session. We will have Dr. Archana Preetam Kale as our session chair. She will be joining us in a while. Till then, we'll be starting with the presentations. First up, I would like to call Thapanapong Sararat to present their study on a disability-centered framework for enhancing accessibility and universal design in web opaque systems, emphasizing visually impaired users in Thailand.
Yes. So I can share my.
Yes, sir.
Okay. สวัสดีครับ Good afternoon, everyone. My name is ถาปนพงษ์สารัตน์ Today I'm honored to present our research titled Disability Centered Framework for Enhancing Accessibility and Universal Design in Web opaque System with a special focus on visual impaired user in Thailand. This work is collaborative effort from the researcher at Mahasarakham University and the University of Phayao. Moving to the background and core problem of our study, web opaque are critical digital gateway for library resource. For visually impaired user, independent access through accessibility technology like screen reader essential. Globally, developers rely on standards such as WCAG 2.1 to make content perceivable and operable. However, as noted by researchers like Spina in 2019 and Wallenweider in 2023, there is a problematic reality. First, many institutions globally still fail to comply with this standard. But more importantly, even when systems achieve strict technical comply, they often fail in actual usability. Automate tests simply missing real-world barrier. This brings us to our primary research gap, with significant disconnect between merely checking the standard box and provide a genuinely accessibility experience. Technical compliance does not equal usability. To address this gap, our study outlined four specific objectives. First is to assess current state of web opaque interface in Thailand from the perspective of visual impaired user. Second, to identify and document the precise technique and design barrier they encounter during the real-world search tasks. Third, to compare how these Thai OPEC align with or derive from international standards like WCAG and Universal Design. And finally, to develop a new disability-centered framework tailored specifically for the Thai context. Regarding our research scope, we focus exclusively on web-based OPEC in Thailand libraries. The primary stakeholders are blind and low vision users who rely on assistive tools. Our analysis concentrate on page structure, alternative text, and navigation, excluding general external database. This ensures our proposed framework is highly targeted and practical. For methodology, we adopt a developmental design-based research approach instead of conducting a static evaluation. This method involves iterative cycle of analysis, design, and refinement with the real-world setting. To ensure our framework is both valid and practical, we engage multiple stakeholders. While blind and low vision users are our primary focus, we also include secondary stakeholders like librarians and system administrator to account for institutional feasibility. Crucially, our data collection relies on mixed evaluation strategy as recent studies such as the Fisher in 2025 have shown automated accessibility checker often capture or only a fraction of actual barrier. Therefore, we pair standard driven WCAG audit with task-based using user testing. We didn't just analyze the code, we observed visually impaired user performing actual library search to capture the true practical usability barrier. For our purpose framework, this framework function This will function more as a development ecosystem rather than just a checklist. It combines three specific components. First is international standard, which include the BCAG and universal design. The second, context challenges address Thai specific issue like language and technology infrastructure and infrastructure, sorry. And third, uh, is later research cycle with involve continuous user participation and task testing, as supported by research from volunteer and beginner, and emphasizing compliance alone is not enough. Therefore, the key takeaway of this framework that using feedback from the people with disability and actionable insights for the developer is a vital part for making web homogeneously accessibility. This session introduced our disability center conceptual framework to guide the design to accessible web system for the visually impaired, ensuring genius accessibility with the Thai context. As despite it, the framework focuses on the three components. The first is disability-centered design principle that address the limitation and specific need for of the visually impaired. Second, identification of user characteristic and need consideration the variety in visual acuity and assistive technology used. And third, accessibility within the web OPAC system, including information, perception, navigation, interaction, and assistive technology compatibility. The key takeaway of this architecture is the structure aimed to connect international standards with Thai linguistics, culture, and technological context, ensure practical and effective implementation. Let's look at the core component. The first core component from our framework is a disability-centered design principle. This principle is rooted in the research, showing the meeting standard alone isn't enough for user struggle or having negative experience. As validated experiment demonstrate a focus solely on comply might not consistently yield meaningful usability or user experience improvement. Therefore, we must incorporate our centric method. Follow beginner proposal, we adopt a participatory approach to gathering feedback. this method aim to transform accessibility complaints into action data for developer. Ultimately, this ensure that people with disability can influence design choice directly rather than just only being accessed at the final stage. For the second component user is a user classification and needs. This framework explicitly differentiates between complete blindness and low vision in classifying user as this directly impact their dependence and assistive to light screen reader or magnification. Asia and colleagues emphasize use need to extend beyond just read text alone. They also include the ability to fully understand the system structure and actually navigate the information retrieval process. Furthermore, in the Thai language, our classification considers the Thai language and script alongside the availability of local assessment tool. Ultimately, this highlights that user needs are not just about the disability itself, they are heavily influenced by language factors standard and develops capacity to access and take edits.
Excuse me, sir. Gentle reminder that you are crossing 9 minutes.
Okay, thank you. Okay, but in our framework, disability aspect corresponded with the BCAG principle, processive, operative, understandable, and robust. However, they are strictly interpreted through lens on specific use tasks. This include perceiving information like outtake, navigate, focus, order, and facet interaction with from via keyboard and ensuring compatibility as assistive technology. Conversely, adapt the dimension to the Thai context require two and criteria. Criteria that reflect real-world that use and use environments. Our researcher data in indicate if system technically meets standard user experience and task success may still be super. That's emphasize that vital importance of evaluating both technical complaint and user experience simultaneously. An outline for methodology before proposing this concept framework is unbent rigorous initial validation process. The first we conduct with the expert. The second we perform consistently check again accessibility engineer evidence. Most important, our validation approach stay focus on user verifying unity. This means the framework is evaluated based on actual task success, reduce interaction friction, and seam compatibility with assistive technology. Uh, detail this includes four main areas. The first is basic search. The second is refined feature. The third is record exploration. And the fourth is access service.
Excuse me, sir. You have crossed 10 minutes. Please conclude now.
Okay, thank you. Uh, for for the conclusion, detail this include the our framework bridge the gap between technical content and user experience. For our future, we plan to validate this framework across Thailand various library type and plan to uh, make another platform like the mobile and make AI support retrieval system. Thank you for your attention.
Yes, thank you, sir. If any of the other participants have any question for sir's presentation, please let me know. All right, thank you, sir, for your presentation.
Thank
Next
you.
up, I would call Rishita Patra to present her study on Ad Genius, adaptive diffusion based generative framework with intelligent user guided styling and LLM driven prompt reasoning for automated advertisement generation.
Yeah, I'll share my screen. Yeah. So my name is Rishita, and our paper is about Ad Genius, which is basically about generating advertisements from Stable Diffusion. And my co-authors are Srishti, Suhani, and Dhruva. So basically, in our current situation or scenario in today's world, generation of ads is not that easy because you need the expertise of designers. And basically, if you do not want to use designers, then in today's world, to use AI, you need to basically use pretty efficient models. And to get those models, you need to pay a lot basically. And apart from that, you also need to fine tune these models in order to be suitable for specific categories, as most of the models won't work in generic terms. So, when it comes to small businesses, it might get difficult for them because they do not have the resources or the money in order to spend for these models, and they do not have the expertise to prompt really well either. So, the current papers which are present for these AI models to generate advertisements are design diffusion, but they require around 4 800 GPUs, and you need retraining for new categories. Then there's ControlNet and T2I adapter, but then these work for task-specific data sets, and you also need to modify the model's architecture for it to work because you need to add a separate extra layer on top of it. And if we need to plainly just prompt a vision model using any prompts that we get from LLM, we might get results, but these results might be inconsistent, and LLMs do not have good design knowledge either. So, the existing gap that is basically there is that there is no design like model which actually takes into consideration our color harmony, motif selection, or visual clarity. So our approach basically aims to solve that. So our approach is that we take a base stable diffusion model and we do not change the architecture of this model. So it's a frozen model, and around it we wrap around lightweight modules in order to make the designing and generation of advertisements easier. So in our approach, we do not require to fine tune our model for any specific categories or for any specific type of products or data sets, and everything is generated in inference time. So we have three lightweight design modules which are layered around the stable diffusion, that is our color module, motif module, and declutter module. So we'll be going in depth in each of these modules in our next slides. So the image that is shown here is basically the system architecture. And this is basically the whole flow of how the advertisement is generated from the beginning to the end. So we thought that for generation of advertisements, we should take minimal input from the user to make advertisements easier. So all we take as input from the user is the product image as well as the description and category of the product. So the product image is passed through the color module, and the color module basically decides what are the colors or the background which would be suitable for that particular product. The category and description is passed on to the motif module. This basically is important because we are deciding the design layout and what exactly will be there in the background of the advertisement. So, combining these two together, we create something known as the creative brief, which is a total idea of how the advertisement will be, like our mood of the advertisement, the campaign concept, and the more details about the advertisement. Together, we combine these and we send it to an LLM. In our case, we've used Llama 3.18b for that, and it generates a very appropriate prompt related to our product, which will result in stable diffusion generating a very appropriate advertisement. So stable diffusion at the end generates an advertisement on that product. And at the end, this advertisement is also passed through the decluttering module. So the decluttering module's main aim is to keep the focus on the product. And if the background is too distracting, then to make it less distracting by blurring it or other mechanisms, which we'll go in depth later. So this is how we get our final advertisement. So going in depth to each of these modules, our first module is the color recommendation module. So in this, we pass the product image, and using k-means clustering, we figure out the dominant colors first. And from these dominant colors, using HSV color theory, we determine that what are the most appropriate colors or the palette generation which would be good for this particular product. We feed these into our llama model, and llama selects from the available options which is the best possible combination of colors that would be good for that particular product category. So we can get an output as something like rose gold with cream accents. Our second module is motif generation, in which we pass the product description as well as category to llama model. Llama generates 5 motifs. So we have given specific prompts as well as templates to this model in order for it to generate appropriate motifs. And the motifs that are generated are passed through this validation framework that we have created, which evaluates a motif on the basis of 4 factors: our specificity, that is, how specific it is to this particular product; complexity, to ensure the focus is mainly on the product; category fit; and coherence. Each of them have been given their respective weights. So combining the scores of each of this, we get a particular score, and we determine that if that score is less than 70%, then we will auto refine it, and we'll send a feedback to the LLM model and tell on which particular factor is the score lesser and what to focus on. So finally, we have a maximum of 3 iterations, after which we get an output. So the motif output can be something like golden marble veins on black. The third module is adaptive background decluttering. So in this, the steps are that we first do multi-scale edge detection, followed by texture guided complexity mask, where we figure out which are the coarse and the fine areas. And on the basis of this, the areas which are more busy, we apply Gaussian blur in those busy regions, and then saturation compression, brightness lift, and we have minimal touch in smooth areas. So in order, like after we applied all these modules, in order to evaluate, we considered 2 evaluation metrics. One is color harmony score and the other is aesthetic score, which is a clip-based model. So our evaluation method was that we generated advertisements for products across 7 categories, spanning from beauty and fashion to food and beverages to general products as well. And in total, we generated about 150 advertisements. How we evaluated is we applied modular voice ablation studies. So we generated advertisements using only color module, only motif module, only decluttering module, and combining all modules together. And the results were pretty significant when we were deciding about the impact on color harmony score. All modules combined together produced the maximum color harmony score, followed by color module. Even though color module is the most determining factor for this, but the overall motif that is generated also plays an important role. So the combination of all modules got the maximum improvement, that is 9.4%. Similarly, for aesthetic score, the combination of all modules brought about the maximum improvement, that was 16.2%, because it affects on all the color, the motif that is generated, and that the main focus is on the product and there's no unnecessary distracting elements in the background. Our results were statistically significant because of our p-values as well as coherence d-value, as we can see in this table, which shows that there was a particular impact. And one more thing is the baseline that we used for comparison was our standard stable diffusion model without any modules on top of it. And all we passed to it is a basic prompt to generate an advertisement on a product. So we took that as a baseline basically. So the generated advertisements are something like this. So like one is on beauty, one is for food, and the other is also beauty. It's like a mist spray. So yeah. So the key takeaways from this project is that we do not require any training for this, and we do not need to fine tune for any particular data set. So that reduces a lot of cost, and makes it more efficient because we do not require a lot of GPUs as well. And this is modular. So each module is plug and play. So anytime we decide to add another module or remove one, that is pretty easy to do. It's pretty design aware and it is statistically validated as well. Some of the future directions on which we can work on are we can work on video advertisement, and we can also work on taking user feedback in order to refine our advertisements more or make the advertisements more brand specific to support their design more. So yeah, we had a great time and it was pretty interesting learning about all of these things, and I hope you guys liked it. Thank you.
Yes, thank you, ma'am, for your presentation. Now, next, I would call Sneha Visweswaran to present her study on Erica nut disease and ripeness detection model.
Yeah, I'll just share my screen. Okay. So hi everyone, I'm Sneha from PS University, and today I will be presenting our work titled Arcanut Disease and Ripeness Detection Model. So this work focuses on leveraging deep learning and computer vision to automate crop health monitoring and maturity assessment in Arcanut cultivation. So these are my team members. So, alkanut is an economically significant crop in India and Southeast Asia. So, however, crop quality assessment is largely performed using manual inspection techniques. So, these methods are, time consuming, it's error prone and inconsistent under real world conditions, such as varying lighting, occlusion, and background complexity. So, because of these limitations, there's a clear need for an automated and reliable system. So, the motivation for this work comes from the real world impact of crop losses. Studies indicate that significant yield loss can occur due to late disease detection and improper harvest timing. So, by automating disease identification and ripeness classification, farmers can make timely decisions, optimize resource usage, and improve overall crop productivity. So, this is especially important for small and medium scale farmers contributing to sustainable agriculture. So the problem is that traditional methods are not suitable for real-time or large-scale deployment. So our objective was to develop an an image-based deep learning system that can detect arcanut diseases, classify ripeness stages, provide real-term predictions, and be accessible through a user-friendly web interface. So our system consists of two main modules. One is the disease detection module, which identifies whether the crop is healthy or affected by a disease. And the next one's a ripeness detection module, which classifies the nut as ripe or unripe. So the system outputs predicted class, confidence score, and actionable recommendations. So this makes it, not just a classifier, but also a decision support system. For dataset preparation, the disease detection dataset consists of approximately 12,000 images, including both healthy and disease samples collected from field data and public datasets. The ripeness datasets consist of approximately 300 images, including ripe and unripe samples collected from plantations. So, as shown in the data set, the data includes multiple, classes such as healthy trunk, leaf, and diseases like yellow leaf disease and stem bleeding, etc. So, importantly, images were captured under diverse environmental conditions and improving. So, this improves model robustness. So before training, all images underwent pre-processing, resizing to maintain uniform input dimensions, normalization to standardize pixel values, noise reduction, and data augmentation. So augmentation also included like rotation, flipping, brightness variation, and these steps improved generalization, reduced overfitting, and increased effective dataset diversity. So this slide represents the overall system architecture. So, as shown in the diagram, the system is divided into two parallel pipelines. The disease detection pipeline, which is of data collection, image pre-processing, model training using detection architecture, classification, and deployment. Similarly, for ripeness detection pipeline as well, we use model training using CNN and classification and deployment. So these two pipelines operate independently and are then integrated into a unified system. Finally, both outputs are combined and deployed via the web application, enabling real-time user interaction. So this modular design, it actually ensures flexibility, scalability, and task-specific optimization. So we used convolutional neural networks for both tasks. So why CNNs? It's mainly because they can automatically learn spatial hierarchies, textual patterns, color distributions, and shape-based features. So these are critical for identifying disease symptoms and ripeness cues. So the architecture consists of an input layer that accepts RGB images, convolutional layers that applies filters to extract features such as edges, textures, patterns. ReLU activation, it introduces nonlinearity, helps the network learn complex representations. The max pooling layers, they reduce spatial dimensions, retain important features, improve computational efficiency. The dropout layers, they randomly deactivate neurons during training and prevent overfitting. And the fully connected layer combines all extracted features, and the softmax layer lastly produces class probabilities. So the overall workflow is image pre-processing, CNN prediction, and web interface. From a user perspective, you upload an image, system processes it, and output is shown instantly with recommendations. So looking at the results, loss decreases smoothly across epochs, accuracy increases and stabilizes. So this indicates that proper learning and there's proper learning and good convergence, minimal overfitting. So coming to the confusion matrix, there's strong diagonal dominance, which shows correct classification across classes. So these are the performance metrics with an accuracy of about 99%. So the model performs well across multiple disease classes such as stem bleeding, bud borer, etc. So this confirms high reliability and strong generalization. So for the ripeness detection, there's a clear separation between ripe and unripe classes in the confusion matrix, and there is some overlap due to visually similar maturity stages. So the training graphs, the loss decreases steadily, metrics improve consistently. So we have got an accuracy of about 97.9%. So the model performs particularly well for unripe detection due to distinct visual features. There's minor errors in borderline maturity stages, and there is complexity in backgrounds. Overall, the model is robust and suitable for real-world use. So to make the system practical, and we deployed it as a web application. It is built using white front end and Python backend. Features, there's disease detection, ripeness detection, and a full scan mode. So the workflow is when you upload an image and you select a mode, there's view prediction, confidence, and recommendation. So it is shown in the screenshots further. Yeah, so these are the screenshots. Here you upload an image. You can either choose a full scan or individually. And here you have your confidence. And next is your report. So, in conclusion, we developed a CNN-based automated system that performs disease detection, classifies ripeness, achieves high accuracy, and is deployed in a real-time web interface. So, this contributes to smart agriculture, faster decision-making, and improved crop monitoring. So, future work includes expanding the ripeness data set, of course, so because it's only 300 images, adding more disease classes to this, improving robustness across environmental conditions, and deploying mobile-based solutions for real field use. So, these are some of the references. Thank you. I would be happy to take any questions.
All right, thank you very much, ma'am, for your presentation. Now, next, I would call Kate Lauren Collot to present her study on BotoSafe, a web app voting platform with multi-factor authentication and data analytics.
Good afternoon. I will share my slide. So, a pleasant afternoon to everyone. I am Caitlin M. Colot, presenting our undergrad study entitled VotoSafe, a web app voting platform with multi-factor authentication and data analytics. So, the main problem addressed by our study is that traditional voting in schools lead to long queues, counting errors and delays, reducing transparency and trust. And some existing e-voting systems suffer from weak authentication and security issues. So, our solution, VotoSafe, is a secure web application for student government elections featuring multi-factor authentication, including OTP, facial recognition, and anti-spoofing, AES-GCM encryption, automated vote tallying, real-time results, and an admin dashboard. However, it requires a stable internet connection and relies on camera quality for facial recognition, and it's tailored for academic and not large-scale election. So, to systematically guide the development of this study, it employed a developmental research design with a quantitative approach, wherein the design process did not follow a single linear path. Instead, each phase allowed the researchers to identify early issues to immediately adjust its components and improve the observed performance and user experience. So, the development process is composed of 6 phases. The first is the requirement analysis, where it determines secure authentication, accurate vote processing, data confidentiality, and efficient election management. Second, system design ensures that security and usability are embedded in the architecture and structure of the VotoSafe system. The third phase is the implementation, which focuses on securing the vote data and real-time analytics by integrating multi-factor authentication, which combines password verification, one-time password validation, and facial recognition with liveness detection, as well as AES-GCM encryption. Fourth phase is testing, which focuses on evaluating the functionality, reliability, and performance of the system. So during this phase, a mock election was conducted to observe how the system performs in a real setting, including the user authentication, vote casting, and result generation. The fifth phase is the deployment. So in this phase, all users interact in the platform. And the last phase is the refinement. So it is where all observations from the user are recorded and used as a basis for improvements. So in evaluating the performance of the system and user experience, quantitative data were collected using the structured survey questionnaire adapted from Sarkawi et al., which was administered before and after the system was deployed. The pre-assessment survey gathered the perception and experience of the students in utilizing the conventional method, while the post-assessment survey measured the key indicators such as usability, perceived security, and overall user satisfaction. So all responses were analyzed using statistical methods such as measures of central tendency and variation. So the overall system architecture and process flow of VotoSafe is shown in the figure. So it describes how each component contributes to the entire election life cycle. So it starts with the user who initiates the access. So at this stage, password hashing is applied, which emphasizes that user credentials are not stored or transmitted in plain text. So after this initial step, the system will enforce a multi-factor authentication process composed of 3 layers. Number 1, the password verification. So after password verification is completed, the system will distinguish between different user roles, either a voter or an admin. So when the user is verified as a voter, it will proceed to the next remaining MFA layers, which are one-time password validation and facial authentication, and the admin will be redirected to the admin dashboard. So during the election procedure, before a vote is submitted, an additional verification step is performed, which validates the identity of the user. So this phase is crucial to prevent impersonation and ensures that each vote corresponds to the authenticated user. So after facial verification, the vote will be encrypted using AES-GCM, which protects the confidentiality and integrity of the ballot. The encrypted vote will be transmitted to the server through an API layer where it is securely stored in a MySQL database. So this process ensures that even if data is intercepted, it remains unreadable and tamper-resistant. In contrast, the backend where the server processes incoming votes and supports real-time vote tallying as votes are casted, the results will be displayed through an analytics dashboard which gives visual insights into voter turnout and participation by program. So the administrative component of the system operates through a separate login interface whose dashboard allows viewing of analytics and results. They are responsible for the key functions such as importing user accounts through CSV files, configure election parameters, manage users, and approve candidate application. So the BatoSafe system begins the first verification process within MFA, which is the user login as shown in Figure 5. Users will have to enter the registered BatoSafe accounts to be able to log in. The system validates the student ID and password before allowing the users to proceed to the next verification process. So upon successful login, users receive a 6-digit OTP via email as shown in Figure 6. So after OTP verification, users proceed to facial registration for the first login, ensuring that only legitimate users can access the voting system. Figure 7 shows the facial registration interface, which is the final process of MFA that appears when the user logs in for the first time. So for new users, facial registration is mandatory except for admins. So this uses Face API.js for recognition and MediaPipe Face Mesh for liveness detection, ensuring that the image is from a real person, not a photo or video. And Figure 8 shows the verification interface with the liveness check when the voter tries to submit a vote. So during vote submission, facial verification with liveness check is repeated to prevent fraud and ensure that only the rightful account owner can vote. So the figure shows that the ASGCM has secured the vote. So the encrypted vote field displays the ciphertext which fulfills the requirement of confidentiality by making the vote unreadable without the secret key. So the entire entry is also protected by GCM's authentication tag, which is an unseen digital seal, which ensures integrity and tamper resistance. So if any part of the vote is altered, this seal will fail to the mandatory check during decryption, causing the system to reject the vote and preserving the election's accuracy. So these are the admin dashboard. So Figure 11 presents the data analytics dashboard of the VotoSafe system that acts as the primary monitoring interface for the admin. So the admin dashboard provides real-time insights showing registered voters, candidates, and turnout rates. So it automatically calculates these figures and updates the election status based on the voting activity. So this automation ensures transparency and easy monitoring for administrators. So votes are counted and displayed in real time through the dashboard as shown in Figure 12. As ballots are cast, database event listeners updates results instantly. So this feature minimizes manual errors and enhances transparency for both users and admins. So Figure 13 shows the voter turnout by program. So the graph visualizes voter turnout by program or department, updating as votes are cast. So this helps admins quickly identify areas of high and low engagement, supporting targeted outreach for future election. So this graph illustrates the distribution of similarity scores between imposter faces. So with a threshold of 0.97 used to determine matches, nearly all imposter scores fall below this threshold resulting in a false acceptance rate of only 0.19% from 6,972 attempts. So this demonstrates that the system is highly effective at rejecting unauthorized users and protecting against impersonation attempts. So, Figure 15 demonstrate that the system achieved 100% tally accuracy, which every submitted vote corrected counted. The participation rate is 96.1%, reflecting that most but not all possible votes were cast as some voters skipped positions. So this indicates both highly reliable vote counting and strong though not complete voter engagement. So, Figure 16 shows that the system achieved 100% precision with all 565 encrypted votes passing validity checks and no duplicates or errors detected. So, this demonstrates that every encrypted vote was properly stored and processed without data corruption. So, overall, the results highlight the system's high reliability and integrity in handling the ballots.
Sorry for interruption, ma'am, but your 9 minutes are up. I request you to
Okay.
end your presentation as soon as possible.
Okay. So, this is the system latency. So it has a minimum of 30 millisecond, median of 435 millisecond, the average of 526 millisecond, and P90 of 1120 millisecond, and maximum of 2834 millisecond. So And the system can process 10 requests per second, supporting real-time operations for small to medium-sized elections. So in summary, the system addresses persistent issues in traditional and digital voting by improving efficiency, ensuring secure and accurate vote processing, and enhancing transparency through automation and analytics. So for future development, it is recommended to upgrade facial authentication with advanced models, deeper liveness detection, and broader user setting for scalability. So these are the references used in this study. So thank you, and thank you for your attention, and we welcome your questions and feedback.
All right, thank you very much, ma'am. Now, next, I would call Eliza Borkute to present a study on consumer trust, security, and awareness as determinants of UPI adoption among private sector employees in Chandrapur. Eliza, ma'am, are you present? Or any of the co-authors of this paper? Tanay Balakrishna, sir, please present your study on enhanced hybrid fact-checking for believable fake news detection.
Yeah, 1 second. I'll share my screen. Is it visible?
Yes, sir.
Okay. Good afternoon. I'm Tanay from PS University, and I'll be presenting our work on enhanced hybrid fact checking for believable fake news detection. So, what our work focuses on is detecting the realistic fake news that closely mimics professional journalism, but it's factually incorrect. So, these are the members that work with me. So, this is the agenda for today of what I'll be presenting. So let's start. So in today's digital world, we know that we use lot, online platforms to like get our news everywhere, and sometimes these newses could also be misleading, and these misleading news can manipulate the public opinion and reduce trust in the reliable sources. So our goal is to work to develop a system that can detect fake news using natural language processing and machine learning techniques, particularly transformer-based models like BERT. So coming to the data set, so this is the data set that we have acquired through online. It's publicly available. And this data set has fields like the text, the title, subject, which helped in training the model more effectively. Uh, Coming to the models and implementation details. So I'll first go through the architecture diagram. So in here, in the data preprocessing phase, we clean, normalize the text and tokenize it using BERT tokenizer, convert it into fixed length sequences. Then coming to the feature extraction, where we use BERT to obtain the contextual embeddings and BiLSTM to capture the sequential patterns. Then in the model selection and training phase, we used adversarial training with FGSM and noise injection to improve the robustness against these paraphrased fake news. Then we further used LLM early screening, where it's a rule-based pattern to detect suspicious content. Then we extracted meaningful claims from these articles and verified them using our trained model and the internal knowledge base, which then produces a claim level credibility score. Then further, we use external web sources by querying the trusted platform to check whether these claims are supported or contradicting. And then finally, we combine all of these using XGBoost and giving us the aggregate score. Now, coming to our model flow, this is how our system works. So basically what the system in the model flow does is the user gives the title and the text. Then the title and the text is received by the backend. The backend then processes it to the LLM early screener for checking if there are any kinds of like conspiracy style content or like some kind of suspicious content in it. And it filter out through that process and then moves it on forward through the BERT and BiLSTM, where again, the BERT and BiLSTM captures the contextual meaning and the sequential flow of the article. Then further, it goes to the claim verification and extraction phase, where the article are broken into individual factual claims And each of these claims are analyzed separately and verified using internal knowledge and trusted external sources. Then finally, this is where the XGBoost comes in, as it like collects all the values from the claim verification part, and it aggregates the scores and gives its final verdict. So coming to the results, so these were the results. We had tested our model before using another learner, that is the logistic regression. And you can see that the logistic regression just gave the same accuracy, 74%. After using XGBoost, there was a 20 to 24% increase in the accuracy. So because of this, we then tried it on our sample believable fake news articles. And out of that, it gave us a 98% accuracy. But when tested out on our obviously fake sample articles, we got around a 58% accuracy. So this you can see the visual of how our front end looks. So here is where the author or the user puts in his title and the text of a paragraph, and this is what the system analyzes it and gives its verdict, saying confidence high because of the score. And the score, we have given like a certain threshold, saying if the score is greater than the certain threshold, then it is likely real or likely fake or possibly fake, things like that. So that is what this image is talking all about. So in conclusion, all I can say is that we have built a hybrid learning approach to detect fake news, where it combines the language modeling, fact checking, and web verification for improved accuracy and robustness, which overcomes the limitation of traditional models by integrating in real world evidence. Our future work is that we want to improve the obviously fake article prediction by trying to implement a two-stage architecture system, and also help in better training of the data. So these are my base references for the making the model. And thank you very much. I'm happy to take any questions.
All right, thank you very much, sir. The next, I'll be calling Tanishq Dhuse to present the study on Halo CME detection using Aditya L1 Swiss aspects data with optimized LSTM networks.
Yes, ma'am. I will share my screen. So, good afternoon, everyone. I'm Tanish Chuse. Today, I will be presenting our project on Halo CME detection using Aditya L1 data with optimized LSTM networks. This work focuses on improving early detection of space weather events using machine learning. So, halocm's are massive eruptions of plasma and magnetic fields from the sun. When they are directed towards Earth, they appear circular and are called halocm's. These travel at a very high speed, around 500 to 1000 km per second, and are responsible for major geomagnetic storms. Aditya L1, developed by ISRO, is first solar observatory launched in 2023. It is placed at the L1 Lagrange point, about 1.5 kilometers from the Earth. This position allows continuous observation of the sun without any obstruction. It is placed 1% distance from Earth and 99% distance from the sun. So talking about the threats, these CMEs can severely impact modern infrastructures. They can damage satellites, disrupt GPS and communication systems, and even cause transformer failures leading to blackouts. So early detection is extremely important. Our motivation was Halo CMEs cause the most intense geomagnetic storms with increasing dependence on satellite and communication. The risk is also too increasing. Current detection methods are mostly threshold based and often give false alarms. So we aim to build a more accurate and automated system. In literature review, multiple studies focus on CME structure, plasma turbulence, and solar wind dynamics. This work help us understand how CMEs interact with solar wind and affect geomagnetic conditions. Other studies focus on ion behavior and highlight open problems in solar wind physics, which motivated our approach. Our main objective is to detect halo CMEs using solar wind data. We extract physics-based features, apply machine learning for detection, and aim to reduce false alarms. We also focus on building a scalable and reproducible pipeline. Our architecture shows our this page shows our complete system architecture. Firstly, we process raw solar wind data from collected from the Swiss aspects data and extract important features. Then we feed this data into machine learning models for prediction. Finally, we analyze and validate CME events and present results through a user interface. For example, the different characteristics which we can take in this include alpha proton density ratio, velocity antistropy, speed gradient, flux spike, etc. And we are using the time series model LSTM, long short term memory. And we have in the user interface, we have provide a Gemini API, then CMA analysis, comparison, and details. Talking about data processing, we collect solar wind data, including particle flux, density, velocity, and temperature. We removed outliers using IQR and handled missing values using interpolation. We also created additional features like alpha proton ratio, velocity gradients, and anisotropy indices. Finally, we normalized the data and converted it into time sequence for training. In the model training phase, we use a stacked LSTM model. Since this is a time series problem, the model has two layers with dropout to prevent overfitting. We trained it using Adam optimizer and binary cross entropy loss. We also used spider cuckoo optimization to tune hyperparameters. We evaluated this model using accuracy, recall, and false alarm rate. Our model shows more than 90% recalls. We reduced false alarms by around 85% compared to traditional methods and validated result using Cactus CME catalog, which is provided by NASA. The tech stack include Python, TensorFlow, and scikit-learn for modeling. For visualization, we used Seaborn and Plotly. And for the interface, we use React and integrated everything using GitHub. This is the mobile app which we created to allow users to see solar events and CME detection in real time. This graph shows feature importance for CME detection. We can see that certain parameters like velocity and flux have higher influence on the prediction. These are the visualizations. On the left, we have the box plot. On the right, we have confusion matrix. These plots show correlation between the solar and will parameters. And these time series plots and distributions show how features behave during CME and non-CME events. This is the web dashboard, which shows CME probability alerts and system insights. This section provides technical implementation details and performance metrics. This interface includes alerts and a space weather assistant bot for better user interaction and classification of geomagnetic storm based on intensity. These are the references which we used in the paper and many more which are included in our research paper. So to conclude, our system improves CME detection using LSTM and physics-based features. It reduces false alarms and provides a reliable real-time detection system. This work demonstrates a next-generation forecasting approach for improved space weather preparedness. Thank you so much, everyone, for listening. I will conclude now.
All right, thank you, sir, for your presentation. Next, I would call Noor Lisa Ramaningtyas to present her study on project-based learning and digitalization quality, evaluating mobile-first web design for SMEs.
Okay, thank you.
Lisa ma'am, are you present?
Yes, I'm share presentation.
Who are you speaking, sir? Are you the co-author?
Nurlisa.
Okay. Yes, sir. Please start with the presentation.
Okay, good afternoon, esteemed college CEOs. Today I will present our research title, Project-Based Learning and Digitalization Quality, Evaluating Mobile First Web Design for SMEs. This collaborative study explores A student-led digital initiative can drive economic and educational progress. To understand the foundation of our research, we must acknowledge that digital transformation is crucial for SME survival. Despite its importance, many small business struggle to establish a digital presence. Because the vast majority of internet traffic now originates from smartphone, implementing a mobile first design which prioritizes small screen for optimal accessibility is no longer an option but a strict necessity. The primary objective of this study is to evaluate a student-led project-based learning model that utilize the Bootstrap framework to meet real-world SME needs. The research aligned with two critical sustainable development goals. SDGs by directly enhancing SME competitiveness and economic growth through digitalization, and SDG 4 by ensuring students gain practical industry-relevant competencies.
Excuse me, sir. I'm sorry for interrupting you, but may I please know your name?
Okay,
Your name,
Lisa,
sir?
Nulis,
Your name is Lisa or Sabo?
Lisa and Sabo.
And who are you? Who is the one talking?
I'm Sabo.
Okay, okay. Yes, sir. So you are
Or
present in the paper. Okay.
yes, okay. Our theoretical framework is built upon the mobile first philosophy. The execute this or student use Bootstrap, which provide responsive grid that significantly reduce development complexity across different devices. Furthermore, we evaluate this set not subjectively but through rigorous system metric. Google Backspace Insight for measuring load speed and visual stability and responsive testing to ensure perfect layout adaptation. We employ a mixed methodology. The quantitative aspect analyze the technical performance of 20 distinct mobile-first web projects, while the qualitative aspect capture the life experience of the participant. Conducted over the month at Universitas Negeri Jakarta, this robust study engages 39 student developer and 10 SME representative to ensure comprehensive data collection. Data collection was comprehensive. Qualitatively, we utilize Google Backspace Insight, the responsiveness tools. While tracking project duration logs, qualitatively, we gathered feedback via Likert scale questionnaires and in-depth interviews. The data was then subjected to descriptive and correlation analysis for the numerical metric, alongside thematic analysis to interpret the qualitative interview transcript. As you can see in the chart on the screen, the technical outcomes were highly successful. The average development cycle was efficient, completing in just over 32 days. Despite this rapid pace, the technical quality was outstanding with desktop backspace averaging 92.3 and mobile averaging 88.7. Most importantly, the average responsiveness level reached 94.5%, validating the effectiveness of the Bootstrap implementation. The development process presented real-world challenges. Students had to actively balance aesthetic with performance, employing lazy loading and image compression to maintain fast load times despite heavy visual asset provided by the SMEs. Furthermore, when client requested non-standard layout, students successfully navigated beyond Bootstrap default setting by writing custom CSS media queries, providing their deep technical adaptability. This graph illustrated a crucial finding, the direct relationship between technical performance and client satisfaction across all 20 projects. The visible alignment between high expect scores represented by the bars and high client satisfaction ratings represented by the line strongly suggests that rigorous technical optimization directly translate into an excellent user experience for the SME client. This conceptual framework map our entire evaluation process. It clearly shows how quantitative metric and qualitative feedback merge to define the final learning outcomes and SME digital impact. Statistically, we found a significant positive correlation of 0.68 between the student perceived effectiveness of the learning model and the actual website responsiveness, confirming that holistic PBL framework lead directly to superior technical results. We must acknowledge our study in limitation. The sample of 20 projects was localized to one university department, and we evaluated immediate technical delivery rather than long-term revenue growth. Moving forward, we recommended longitudinal studies to track to the long-term economic sustainability of these SMEs, as well as expanding this research to multiple interaction and potential integrating AI-driven analytic into evaluation framework. In conclusion, this research demonstrate a powerful dual contribution to the sustainable development goals by delivering highly responsive digital asset. We actively support SME economic growth under SDG 8. Concurrently, the project-based learning model successfully equipped our students with vital industry-ready skill fulfilling the mandate of SDG 4. The study validates that bridging academic theory with real-world SME challenges benefit both the educational sector and the economy. That concludes my presentation. Thank you for your attention.
All right,
Okay.
thank you, sir, for your presentation.
Thank you.
Now, next is by the same author, Sabo Harmavan, to present his paper on student-driven development of SQL-based inventory systems for MSMEs integrating ChatGPT and SDG 12.
Okay, thank you, Miss. I'm again here. Okay, good afternoon, respected colleagues. Today I am honored to present our research title, Student-Driven Development of SQL-based inventory system for MSMEs, integrating ChatGPT and SDGs 12. This collaborative study examines how combining student-led software development with artificial intelligence can drive sustainable digital transformation for small business. Okay. Next, to understand the context of our study, we must recognize that while digital transformation is vital, MSMEs often lack the financial and technical resources to implement complex digital solutions. A critical area affected by this is inventory management, which is the cornerstone of operational efficiency. Furthermore, effective inventory control directly supports sustainable development goals to allow responsible consumption and production by minimizing waste and optimizing the use of resources. Our research proposed a particular low-cost solution to this problem, a student-driven development model for creating customized SQL-based inventory system. Crucially, well-integrated ChatGPT as an AI code developer to accelerate the coding process and enhance system robustness. Our primary objective is to evaluate how this sudden lead AI-assisted approach can effectively bridge the digital divide for MSMEs while maintaining high technical standard and user satisfaction. Regarding our methodology, we utilize a quasi-experimental mixed method approach. This research was a collaborative project involving information system students and 30 local MSMEs. These businesses were specifically choose because they had no prior formalized digital inventory system. Under our structured framework, the students were tasked with designing and deploying fully functional custom SQL-based system tailored to the exact need of their MSME partner. As illustrated in the framework on the screen, the core technical requirement was building relational SQL-based databases. To achieve this, student integrated ChatGPT across three critical development paths. First, from engineering for complex input validation in ensure data quality. Second, generating and debugging specific SQL queries for stock movement. And third, optimizing the logic for summary report, such as low stock alert. To rigorously evaluate the system, we measured 3K variables 6 weeks after implementation. We measured stock accuracy and on a 10-point scale to track deviation between physical and recorded stock. Reporting efficiency was also measured on a 10-point scale to compare reporting speed against previous manual method. Finally, we assessed use satisfaction via a survey to capture the MSME owners' perceived usefulness and system as of use. FOS. Our quantitative result, we highly encouraging demonstrating significant operational enhancement for the MSMEs. On average, the system has achieved 7.7 in stock accuracy and 7.63 in reporting efficiency. Furthermore, the overall user satisfaction score an impressive 8.17 out of 10. The very low standard deviation of 0.72 in user certification indicates that this positive reception was consistent across the diverse group of participating MSMEs. When analyzed or studied and utilized ChatGPT, a clear pattern emerged. In the 5T project where ChatGPT was primarily used for input validation, the system achieved the highest score input user satisfaction and stock accuracy. This highlight a critical lesson using AI to enforce strict data validation rules at the input stack directly ensure data integrity, which is the absolute foundation of any reliable inventory system. A technical review of the underlying code reflects a strong focus on active transactional data handling. The most frequency SQL command was select, utilized heavily for data retrieval and reporting. These were closely followed by the update command, essential for adjusting stock level in real time after a transaction. This pattern confirmed that the MSMEs are actively utilizing these databases for dynamic day-to-day inventory monitoring. Start visualize the performance score based on how ChatGPT was utilized. Will or ANOVA testing indicated that the type of AI usage did not create a statistically significant difference in the sample size. The descriptive trend are clear. Project that prioritize AI for input validation consistently or performance the order. This reinforce or finding that data integrity is the primary driver of system effectiveness in a real-world business environment. Crucially, this technical success translates directly into achieving sustainable development goals 12 by achieving high stock accuracy. We eliminate informational gaps, which directly prevent over ordering and and subsequent waste of resource. High reporting efficiency prevents stock out and stabilize local supply chains. Furthermore, the high user satisfaction ensure that this responsible consumption habit are maintained by the MSMEs over the long term. To conclude, our study proved the integrating AI tool like ChatGPT into student-driven development framework create highly practical and scalable solution for MSMEs. This model not only accelerate digital transformation at the grassroots level, but also examine the role of higher education in driving global sustainability targets. Moving forward, we aim to expand this model across more diverse industrial sector and conduct longitudinal tracking or to measure long-term economic impacts. That concludes my presentation. Thank you for your attention. Thank you.
Yes, thank you so much for your presentation.
Okay.
Rachna ma'am, do you have any questions for sir?
Yeah, I just wanted to ask, it was a nice presentation. I just wanted to know what you have done for report optimization, sir. One of the component was report optimization. So which technique or what algorithm or by what means you have taken that report optimization part?
Okay,
Am I
miss. Okay. Optimization part.
report optimization was one of the component, na?
Okay, our finding come from the student-driven development supported by ChatGPT significantly enhance inventory management practice for MSMEs and align with SDGs 12. The system achieve high average score in stock accuracy, reporting efficiency, and user satisfaction. Ultimately, integrating AI tools like ChatGPT into student project can deliver practical, scalable, and sustainable digital solution that drive MSME digital transformation.
Okay.
All right. Thank you very much, sir, for your presentation. Next, I would call Jitesh Kriplani to present his study on the impact of social media influencers on consumer preferences and purchase intention, an empirical study. Jitesh Kriplani or any of the co-authors? I repeat, Jitesh Kriplani or any of the co-authors of this paper? All right. Tejaswini Borkar, ma'am, are you present?
Yes, sir. Yes, ma'am.
Yes, ma'am. Please present your study on the role of artificial intelligence in stock market prediction, opportunities, and challenges.
Yes, ma'am. Good morning, everyone.
Are you sharing your screen?
Tejaswini, ma'am. I believe she must be trying to share
Yes,
her
ma'am.
screen.
Yes, ma'am.
Okay.
Good morning, everyone. I am Tejaswini Borkar. Today, I am going to present my topic, the role of artificial intelligence in stock market
Tejaswini, can you
prediction.
make it full screen? Tejaswini?
explain करते Good evening. Good morning, ma'am. I am Tejaswini Rajuborkar. Today I am going to present my topic, the role of artificial intelligence in stock market, prediction, opportunities and challenges. Introduction. The stock market is dynamic and complex. The stock market it changes very fast. Price go up and down every second. Many things affect it, so it is not easy to understand. Second, influenced by economic and global factors. The stock market is affected by the economic and world event. For example, inflation, interest rate, war, and government decision can changes stock price. Third, traditional analysis is less effective. Old method of study the market like chart report are sometimes slow. They may not handle huge amount of data quickly. So they are not always accurate today. Fourth point, the AI improves speed and accuracy. Artificial intelligence AI can analyze large data very quickly. It helps investor makes better decision by finding patterns and prediction trends faster. Fifth point, challenges. Using AI also has problems. First is privacy. Privacy means personal and financial data must be protected. Second is ethics. Ethics means AI should be used fairly and most manipulated markets. Third is regulations. Government needs rules to control AI use in trading. Literature use. Uh, Themes AI in shows market forecasting, level review, authors
Tejaswini, Tejaswini, you can, instead of reading the literature review, just show us what final gaps and what problem statement have you find out.
Yes, ma'am. First is AI stock and market forecasting में needs needs for more real time needs for more real time explanation AI model and AI algorithms means AI enhance predictive accuracy, market efficiency, and more trade executives challenges including fitting and bias.
Tejaswini, you're not audible.
Hello, Tejaswini ma'am.
Yes, ma'am.
Yes, ma'am, please continue. We cannot hear you, ma'am. Are
Yes,
you
ma'am.
having any
Yes,
technical?
ma'am. 1 minute.
You can read it slowly if you have any problem. No issues.
My screen is not visible, ma'am. That's why.
It's visible to us, Tejaswini.
Yes, ma'am. Now it's visible. Advanced AI techniques in trading need for multidisciplinary ethical and AI skill. Hello, ma'am. Screen is not.
It is visible to us. You
Yes,
can go
ma'am.
back, go to the next slide and tell us at what slide you are actually.
Not next slide is wait.
You can share the screen again.
Okay, ma'am.
Stop sharing and then again you can reshare.
Sorry for inconvenient, ma'am.
Go ahead, go ahead.
Continue my presentation. Research objectives to check how AI helps in making better and more accurate, predictable, and faster trading. Taken to find and understand the main issue such as ethics, rules, and transparency in AI-based trading. Third is to study how AI trading affect market changes, volatility, and risks compared to traditional trading. Research methodology, experimental framework to evaluate LM in trading, AI models, ChatGPT, Perplexity AI, and Grox. Third is use of historical and real-time market data. Fourth is AI generated trading signals, forecasts, and strategies. Fifth is comparative analysis based on accuracy and insights. Sixth is performance and qualitative evaluation, returns, risks, and interpretability. Algorithms, data collections, stock prices, indicators, and news. Second is data clearing, removes errors in data. Third is feature selection, choose important area. And fourth is predictions. AI predicts the market. Fifth is model training, means train AI models. Evaluation, compare and result. Conclusion, LLMs enhance trading strategy development. AI strategies are traditional, not always better. Third is validations and risk management are essential. Fourth is AI support, not replace human expertise. Fifth is human is equal to hybrid AI plus financial models. Future scope. Cross countries comparison of geopolitical reliance. Example, Europe, Asia. Europe, Asia. Second is role of fintech and digital systems in reducing market stocks. Third is talk of long-term economic impact, conflict of development and policy. Use of high frequency financial data analysis, short-term reactions, behavior finance analysis of investor reactors and geographic. These are reference in my papers. Thank you.
Rachna ma'am, any questions?
Tejaswani, what is the difference between technical analysis and fundamental analysis? And which is more preferable for stock prediction, according to you?
Fundamental analysis.
Why?
Because ma'am, fundamentally analysis more accurate data.
How more accurate data in fundamental? Alone fundamental can assist in the accurate data?
Yes, ma'am.
And what will be the advantage of using explainable AI with this in prediction?
We can do the stock invested in stock better.
ठीक है.
Okay, ma'am. Thank you.
Yes, thank you, ma'am. Now, this is the last call for Eliza Borkute. Eliza Borkute or
She is
any
in
of
paper.
you? Jitesh Kriplani.
Excuse me, ma'am.
Yes, ma'am. Yes, Tejas, ma'am. Are you trying to say
Ma'am,
something?
they were there in 10 to 15 minutes. Actually, they were in paper.
Who, ma'am?
Ma'am, what?
Ma'am, Jitesh or Eliza?
Both will join in 10 minutes.
Good morning,
Uh,
madam. Good afternoon, madam.
Yes, good afternoon, sir.
Can I start my presentation?
Sir, what is your presentation? What is your paper title?
693 and second one is 761.
Sir, are you sure you are in this session?
Yes, ma'am. 697 and second ID dot 761.
All right, sir. Please give us a minute. I'll confirm it with you in a minute. All right, everyone,
Yes.
please wait for a minute.
Sir Pankaj, your virtual room is virtual room D. And
Yes,
you
ma'am.
have to
Virtual
be
room D.
present there for your presentations. Yes.
Okay.
And this is virtual room A.
Okay, sorry.
Okay, yeah.
Right, hello again. Since we are on a time constraint, I will be concluding this session now. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference, and we will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, hence kindly cooperate with the team of ICTIS 2026. Lastly, I would kindly request everyone to please turn on your cameras for a quick snapshot of this virtual conference. Alright, thank you everyone. Have a great day ahead and stay safe. Thank you.